Hello guys. This will be learning video from RV College of Engineering. Myself Bharat and my teammate name is Anvesh Rao. The topic is stock price prediction using ML algorithms. The outline of the presentation will be introduction, theory, design methodology, and results. At last, and the last will be conclusion. Introduction. Objective of our presentation is the project is forecasting a stock price of ABC Industries Limited for next 30 days, providing reliable and accurate predictive model based on the historical data. The significance will be it highlights the practical application of machine learning and data analysis in finance, aids investors and financial analysts in market informed decisions. Methods we used are time series analysis, regression models, data pre-processing techniques. These are the five main models we consider here. First one will be LSTM, long short-term memory. It is a type of recurrent neural network designed to model sequential data and time series, effective in capturing long-term dependencies and patterns in stock price. And the second will be SVR, support vector regression, a regression model that finds the best fit in hyperplane in high dimensional space, useful for predicting continuous values like stock prices by minimizing prediction error. The third will be RF, random forest, and an ensemble learning method that combines multiple decision trees, excels in the regression task by averaging prediction from different trees to enhance the accuracy and reduce the overfitting. The fourth will be GRU, gated recurrent unit. It is similar to LSTM but with a simplified architecture, efficient in learning temporal pattern in time series data, often used for stock prediction. And the final and last model which we consider here is KNN, K nearest neighbors, a non-parametric algorithm that predicts based on the proximity of data points in the feature space. Simple yet effective, but capturing the pattern by comparing the similar stock prices. Theory behind the model here is we collect the data. Data collection period is from January 1st, 2015 to March 2nd, 2024. Uh, Mainly, we consider four data attributes, which are opening price, highest price, and low price, and closing price of the day. And volume will be for total number of shares traded on the particular day. Uh, Next. Uh, we used a Python programming language, and the key libraries are NumPy, efficient in numerical computation and array operations. And the second will be Matplotlib, used for visualization of the stock data. Third will be SciPy, advanced scientific computing for complex data analysis. The fourth will be Scikit-learn, a tool for data pre-processing, machine learning algorithm, and model evaluation. The deployment framework here we used is Streamlit, interactive web application for real-time data input and stock price prediction. Now the presentation will be continued by my teammate, Anvesh.
So we considered four major prices. The first one is opening price, then closing price, high price, and low price. So the plot of all the four prices has been plotted with respect to each year as shown in the left side of this image. So and then we have also plotted the histogram on the right side, which basically uh, takes into account the frequency of repetition of each of the price. This is just for the analysis purpose or just for the pre-processing of the data. For the five models that we have implemented, we have considered three major parameters. First one is the RMSE or root mean squared error. The second one is the mean absolute error, and the third one is mean squared error. So RMSE basically calculates the square root of the average square differences between predicted and actual values. So it is highly sensitive to outliers. So not so as much as mean squared error, but still it's a useful metric for understanding the overall accuracy of the model. The second parameter is mean absolute error. It's quite straightforward as well as a balanced measure for error magnitude. It is less influenced by outliers. So by definition, we can say MAE is the average of absolute differences between predicted and actual values. The third parameter is mean squared error, which is the average of square differences between predicted and actual values. So since there is a square term appearing here, so the larger errors are more magnified, and MSC largely varies if there are large number of outliers, thus emphasizing the significant discrepancies in predictions. Another parameters that we consider for each of these models is R2 score, which is also known as coefficient of determination. So it basically measures the proportion of variance in the dependent variable that is predictable from the independent variables. So its purpose is to indicate how well the model explains the variability of the data. Its value can range from 0 to 1. So an R2 score of 1 basically implies perfect prediction, whereas R2 score of 0 implies that the model is not fit for the data. Higher the R2 value, we can say that the particular model is fit for the data, whereas lower the R2 value corresponds to that the model is not fit for the data. So as you can see here, in our particular case, we have found out that GRU for the test R2 score is kind of like 0.87, which is the highest among all the four implemented algorithms. The second one is the 0.84, which is random forest, and the worst algorithm for this particular case is SVR, so which has the test R2 score as 0.49. And these are the different comparison graphs that we have obtained. As I had previously mentioned, the R2 score for SVR was very low, so which is evident from this graph, as there is a quite difference between the original stock price as well as the predicted stock price. Whereas in RF regressor, even though the peaks as well as crests are not that much detected, still the predicted stock price almost follows the original stock price. The same can be said about KNN as well. Uh, but in LSTM, one can see that there is large correlation between the tested as well as the original. Between the predicted as well as the original stock price. Now coming to the GRU almost completely follows the original stock price. Uh, so from this graph, it is evident that GRU is best suited for this application in our current scenario. But there is one drawback here as well. As the time goes on, as the number of years we consider is increased, then the prediction may fall short compared to that of original price. So coming to the applications, we have various applications for model evaluations. Like it can be used for comparing models, it can be used for selecting features, it can be used for forecasting economic situations, as well as for scientific research. So, so we can say that employing all these models gives us a valuable insights on how to analyze various stocks, how to use various parameters such as R2 score, RMSC, MAE, and MSC for predicting stock values. So this is our project. Thank you.